If you think space is an empty, silent void, you're mistaken. Strange worlds are quietly orbiting giant gas planets. Worlds that are even more terrifying and mysterious than the planets themselves. Look at Io, Jupiter's moon. Home to the most extreme volcanic activity ever observed. More than 400 active volcanoes erupt lava at temperatures exceeding 1,600 degrees Celsius, constantly resurfacing the moon in a living hell of fire. Or beneath the icy shells of Europa and Enceladus. Two frozen worlds that sustain vast liquid oceans hidden below their surfaces. Then there is Titan, a world wrapped in a hazy sky, where rivers and seas are made of liquid methane at -179 degrees Celsius, an inverted version of Earth. This is only the beginning. A realm where each moon becomes a place where the laws of physics are stretched in unexpected ways. If life exists there, what would it look like? And are we truly ready to discover it? Join us as we step into this journey of exploration right now. Let's start with Titan, Saturn's largest moon, which could be considered a planet of methane. A strange world where rain doesn't fall from condensed water vapor, but from liquid methane. And rivers flow not with water, but with hydrocarbons. Titan challenges every definition of life that we've ever known, making scientists wonder. Could life exist without water, without light, yet still thrive in perpetual cold and darkness? Since NASA and ESA's Cassini spacecraft began orbiting Saturn in 2004, Titan has quickly become the star of the mission. Beneath the dense golden haze that blankets its surface, scientists discovered that these were actual lakes and seas filled with liquid methane and ethane. Where the Huygens probe detached from Cassini and plunged through Titan's atmosphere in January 2005, all of humanity held its breath. After 7 years of space travel, this small spacecraft touched down on a world more than 1.4 billion kilometers away from Earth. In a few short hours, Huygens sent back the first images from Titan's surface, a landscape covered in rounded ice pebbles, eroded by ancient methane flows. Cassini's analysis revealed that Titan possesses a closed climate cycle. Similar to Earth's water cycle, methane evaporates from its seas, condenses into clouds, falls as cold rain, and then flows back into deep lakes and dark oceans. However, there is one fundamental difference. Methane, not water, is the lifeblood here. At temperatures around -179 degrees Celsius, water becomes as hard as rock. But methane remains liquid and forms the foundation of Titan's weather. In essence, Titan is a parallel Earth, but with all of nature's laws reversed. According to a 2023 report from NASA's Jet Propulsion Laboratory, gravity measurements from Cassini suggest that Titan might harbor a massive underground ocean beneath its thick ice shell, potentially containing ammonia-infused water, a natural antifreeze which keeps water in liquid form even at extremely low temperatures. This means that beneath its icy surface, a stable and energy-rich environment might exist. The presence of ammonia-infused water suggests a potentially life-sustaining environment beneath the ice. Astrobiologists consider Titan a prime candidate for life beyond water. In an environment where methane acts as a solvent instead of water, biological reactions could operate on completely different principles than those on Earth. Some researchers even speculate that, if life does exist on Titan, it could be thriving just beneath its surface, within methane-rich mud layers or in deep hydrocarbon lakes. Titan is also a massive natural laboratory for prebiotic research. When ultraviolet light from the sun interacts with its upper atmosphere, it creates numerous complex organic compounds known as tholins, molecules that may be the building blocks for amino acids and nucleotides, the foundations of life. For this reason, NASA is preparing for the bold Dragonfly mission, set to launch in 2028 and reach Titan in the early 2030s. If Dragonfly finds evidence of biological reactions or complex organic compounds, it would not only change our understanding of Titan, but also transform our understanding of life on Earth. Titan shows us that life might not need light, water, or comfortable temperatures. It could arise from cold chemistry, operating slowly in the darkness for billions of years, waiting to be discovered. The data left behind by Cassini, combined with the upcoming Dragonfly mission, could provide the answers humanity has been waiting for centuries. If you enjoy this and don't want to miss out on more exciting discoveries, subscribe to WUFO right now. Next, we'll continue our journey to Io, Jupiter's volcanic moon, where continuous eruptions show the overwhelming power of nature that the universe can unleash. While Titan amazes us with its methane seas, Io reveals the destructive power of eternal volcanoes. It is the most volcanically active moon in our solar system. Continuous eruptions of lava have completely changed the way we perceive life and geology in the universe. Io is a celestial body torn apart from the inside, with hundreds of active volcanoes constantly erupting, spewing sulfur, sulfur dioxide, and molten lava. Each eruption can send material soaring to altitudes of up to 500 kilometers. The spectacle, first discovered through the Voyager and Galileo missions, reveals a world that never stops changing. Io's surface, with streaks of molten lava and towering plumes of smoke, makes it a natural laboratory for geological eruptions. But what gives Io this destructive power? The answer lies in the phenomenon of tidal heating. The incredibly strong gravitational pull of Jupiter, combined with the interactions between its neighboring moons, Europa and Ganymede, creates a continuous deformation mechanism in Io's orbit. As Io moves around Jupiter, its slightly elliptical orbit causes the distance between the two celestial bodies to change, generating tidal forces that stretch and squeeze Io's surface. In this way, Io is continuously bent, generating enormous friction inside, converting this energy into heat, which partially melts its core. This energy provides the necessary heat for Io's constant volcanic activity. But it's not just lava and high temperatures. Io is also a massive generator in space. As Io moves through Jupiter's powerful magnetic field, a strange phenomenon occurs. Io generates a powerful electric current, estimated to be millions of amperes, flowing through itself and then shooting into space. This interaction creates a huge plasma tube known as the Io plasmaturus, where ionized particles are expelled, creating an intense radiation belt around Jupiter. This eruption not only lights up Jupiter's sky, but also creates extreme conditions for all the moons surrounding the giant planet. So, could all this chaos be a sign of a system constantly being torn apart? Or is Io actually the source of energy for the other moons? The power of Io could be the prerequisite for life on nearby moons. For instance, Europa, another of Jupiter's moons, might harbor a warm underground ocean thanks to the tidal energy Io generates. Therefore, Io is not just a lava forge, but also a key component in the cosmic energy system, nurturing environments beyond itself. Io is not just a geological furnace, but an endless source of power where fire, heat, and energy never stop burning. And as we delve deeper into the moons of Jupiter, could Io be contributing to the continuous development of life in the frozen reaches of the universe? While Io represents the raw power of nature with its molten lava and constantly erupting volcanoes, Europa presents a chillingly different world, one wrapped in thick layers of ice that hide a secret capable of completely changing our understanding of extraterrestrial life. Europa, in orbit around Jupiter, is one of the most fascinating celestial bodies in the solar system. Its ice crust, ranging from 15 to 25 kilometers thick, covers a vast liquid ocean, which scientists estimate could hold twice the amount of water found on Earth. Despite the icy exterior, beneath the surface lies an ocean containing all the necessary elements for life. The cracks on Europa's surface are signs of ongoing geological activity beneath the ice. Europa has become one of the most promising places in the search for life beyond Earth. Although it doesn't receive sunlight, the tidal energy from Jupiter provides an endless source of power beneath the ice. Data from NASA's Galileo mission revealed that the interaction between Europa and Jupiter creates powerful tidal forces, causing Europa's ice shell to continuously flex and crack. Recently, spectral analysis of surface cracks on Europa has detected the presence of sea salts and organic compounds, suggesting that chemical exchanges are occurring between the ocean beneath and the surface. These organic compounds are not just indicators of a potential ecosystem, but also evidence of chemical processes similar to those found in the deep oceans of Earth. On Earth, hydrothermal vents have sustained life in the ocean depths in complete darkness, fueled only by chemical energy from reactions between water and molten minerals. Could Europa host a similar ecosystem beneath its ice? The issue lies in whether life could arise and thrive in an ocean enclosed in eternal darkness and subjected to immense pressure. Geological models suggest that the ocean floor on Europa may come into direct contact with a molten silicate core, opening the possibility of hydrothermal volcanic activity beneath the seafloor. These vents could provide enough energy to support a chemosynthetic ecosystem, where life could develop without sunlight. Microorganisms living in Earth's deep-sea hydrothermal systems could serve as a model for life in the darkness beneath Europa's oceans. Missions like Europa Clipper, scheduled for launch in 2024, promise to provide key answers about the potential for life on Europa. Europa Clipper won't land on the surface but will conduct 50 flybys, gathering data on Europa's underground ocean and atmosphere. Using tools like ice-penetrating radar to measure the thickness and depth of the hidden ocean beneath the surface. This exploration is not only a significant step forward in the search for life beyond Earth, but also opens a new era in the field of astrobiology. Europa, with signs of a potential ocean beneath its thick ice, is one of the most crucial locations in the quest for extraterrestrial life. We're not just looking for water, but for creatures that could exist without sunlight, relying solely on chemical energy from the seafloor, where life could thrive in the darkness and cold. Will Europa be the place where we discover extraterrestrial life for the first time, after thousands of years of searching? To find the answer, we must continue this journey after discovering the potential underground oceans beneath Europa's icy shell. We continue our journey to another moon of Jupiter, Ganymede. Ganymede is not only the largest moon in the solar system, but also one of the most mysterious celestial bodies that scientists are still trying to understand. Ganymede possesses its own magnetic field, placing it in a unique category in planetary research. This magnetic field proves that beneath its thick ice layer lies a molten metallic core similar to Earth, where flowing liquids create a dynamo effect, generating a protective magnetic field for the moon. Because of this, Ganymede has its own magnetosphere, a magnetic field surrounding the moon, which reduces the impact of high-energy particles from Jupiter, creating unique auroras not found on any other moon in the solar system. But the magnetic field is just the beginning of Ganymede's larger secrets. What makes Ganymede even more fascinating is the thick ice layer that hides a massive underground ocean beneath it. Based on data from the Hubble Space Telescope and studies from the Galileo spacecraft, scientists have confirmed that beneath the 15 to 25 kilometers thick ice, Ganymede may have a liquid water ocean that contains twice the amount of water found in all of Earth's oceans combined. The existence of this ocean raises an intriguing new question. Could an ocean beneath the ice with a layered structure support life? Similar to Earth's underground oceans, where microorganisms thrive without sunlight? The stratified model of Ganymede's ocean suggests that an ecosystem could exist within the liquid layers trapped between high-pressure ice layers, similar to the ecosystems found on Earth's ocean floors, where life thrives on chemical energy from hydrothermal vents. This brings new hope for the possibility of life existing in a place once thought to be impossible. Recent discoveries about Ganymede's iron core also suggest that this molten metallic core could provide enough energy to sustain geological activity for billions of years. This is an important factor in understanding why Ganymede could maintain a long-term ecosystem beneath its ocean without sunlight. When high-energy particles from Jupiter interact with Ganymede's magnetic field, they not only create auroras, but also provide a sustainable energy source for chemical reactions beneath the ocean. Could life truly develop in a stratified ocean, where ice and liquid water are stacked on top of each other? Could Ganymede's powerful magnetic field create a safe and stable environment for life, protecting it from the destructive radiation from Jupiter while Europa is exposed to these harmful rays? Ganymede, with its unique ice structure, active iron core, and ability to maintain an underground ocean, could be a promising candidate for life's development, potentially even surpassing Europa in its ability to sustain living conditions. The European Space Agency's Jupiter Icy Moons Explorer mission, set to launch in 2023, will conduct further research on Ganymede, closely examining the auroras on Ganymede and studying the structure of its underground ocean, with the goal of determining whether Ganymede could support life. Could Ganymede be the place where we discover extraterrestrial life, where organisms exist in the darkness of an underground ocean, beneath a freezing ice shell? Continuing our journey through the wondrous moons of Jupiter, we move to another moon in the Saturn system, where the potential for life becomes a question that may be answered. Enceladus, though small, with a diameter of only about 500 kilometers. Enceladus harbors a great secret that not every corner of the universe can conceal. Beneath its icy surface, a vast hidden ocean may be the place where life is thriving in ways we never imagined. The first marvel was the discovery of ice plumes erupting from cracks near Enceladus's southern pole. These plumes are not simple vapor streams. They expel liquid water, ice particles, and steam at such high velocities that they form a faint trail in Saturn's orbit. This is strong evidence for the existence of a liquid water ocean hidden beneath Enceladus' thick ice, providing a window into what's happening beneath the Moon's surface. Data from flybys of these plumes revealed the presence of organic molecules, compounds such as methane, carbon dioxide, ammonia, and complex carbon chains, all fundamental building blocks of life as we know it. These organic molecules strongly suggest that beneath the frozen surface, a potential biosphere exists. One of the most impressive discoveries from Cassini's flybys was the presence of molecular hydrogen in the plumes. On Earth, hydrogen is typically produced from chemical reactions between hot water and mineral-rich rocks. This further supports the notion that liquid water and chemical energy may be creating a hospitable environment for life in Enceladus's underground ocean. A condition that doesn't require sunlight but relies solely on chemical reactions to sustain life. Another discovery from Cassini's flybys was the presence of nano-sized silica in the plumes. These silica particles could only exist if the temperature at the bottom of Enceladus's ocean is around 90 degrees Celsius. This reinforces the idea that the hydrothermal vents at the ocean's floor are strong enough to provide an ideal environment for life. Just as we find deep-sea hydrothermal vents on Earth, these vents could serve as a life source for organisms in a lightless environment. Could this lead to a chemical ecosystem similar to those of Earth's deep-sea creatures that rely on chemical energy? The European Space Agency is preparing for the next exploration missions, specifically designed to collect samples from Enceladus's plumes, providing an opportunity to obtain material directly from the Moon's underground ocean without having to drill through its thick ice. This presents a golden opportunity to gather direct evidence of life, looking for biological traces such as cells or amino acids, if they exist, along with future exploration missions. Enceladus will remain a shining beacon in the search for life in the vast universe. After exploring the icy moons of Jupiter, such as Europa, Enceladus, and Ganymede, we turn our attention to a distant corner of the solar system where a strange and mysterious moon resides. Triton, the largest moon of Neptune. Although Triton is relatively small compared to moons like Ganymede, it possesses unique characteristics and an intriguing history, making it one of the most important targets in the search for life beyond Earth. In fact, Triton is an object from the Kuiper Belt, the icy region beyond Neptune. This is extremely rare for moons in the solar system, making Triton an extraordinary subject of study in the quest for extraterrestrial life. One of the most peculiar phenomena on Triton is its cryovolcanism. Despite its small size, Triton's surface is significantly influenced by nitrogen ice eruptions, creating powerful geysers that shoot material from beneath the surface into space. These ice plumes are clear indicators of ongoing geological activity beneath Triton's frozen crust. Unlike the volcanoes on Earth, where molten magma erupts, Triton's eruptions consist of nitrogen ice and gases venting from below. Like Enceladus, Triton could have an underground ocean, possibly a liquid water ocean lying beneath its thick, icy shell. Another intriguing aspect is that, despite being so far from the Sun, tidal energy from Neptune still keeps Triton active, making this moon far from being a completely quiet world. The immense gravitational pull of Neptune constantly stretches and compresses Triton in its orbit, generating internal friction and producing heat. This tidal force is the primary energy source that sustains life beneath the surface of Triton. As the internal temperature of Triton keeps liquids or semi-liquids from freezing completely. It could create a stable environment for microbial life to thrive. Does Triton really have a subsurface ocean? Scientists have used geological models and data from NASA's Voyager 2 to estimate that Triton may contain a layer of liquid water between its nitrogen ice and water ice crust. This not only opens up the possibility of an underground ocean, but also suggests that life could develop in a sunless environment where chemical reactions provide energy for microorganisms. Some current fluid physics models suggest that liquid water could exist in a completely isolated environment beneath Triton's surface. Hydrothermal processes at the ocean's bottom could be similar to those found at Earth's ocean depths, where life thrives without sunlight, instead rely on energy from hydrothermal vents. The discovery of cryovolcanism, combined with the potential for liquid water and chemical energy beneath the surface, makes Triton a strong candidate in the search for extraterrestrial life, and opens up unexpected possibilities for life in the universe. We have traveled through the most bizarre worlds in our solar system, from Titan's methane seas to Io's fiery eruptions, and the hidden oceans of Europa and Enceladus. These moons have proven that energy and life do not have to depend on the sun, but can be sustained by tidal forces and chemical reactions hidden deep within the icy crusts. Each moon stands as evidence that the universe is far richer than we ever dared to imagine. Science has moved beyond the assumption that Earth is the only unique world. Future missions, from Europa Clipper to JUICE, are not just exploratory flights. They are humanity's pinnacle efforts to unlock the ultimate mysteries of the solar system. These strange worlds are not merely bright dots in the night sky, but potential places where the greatest question of all might be answered. Are we alone in this universe? The answer, perhaps, is waiting, frozen beneath the icy shell of one of these moons, just a probe's flight away. Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.